Okay, welcome. It's Monday. Uh, Team Impact. Sorry, I'm trying to get my camera squared away there. Um, so, anyway, last week before Christmas holiday break, we really got a 4-day work week here. So, I don't know how many lessons. I think we have 3 lessons or 4. So it's going to be interesting to see how this thing plays out at the end. But we're going to keep pounding on. So let's get into it. Rational numbers. We did a little bit of this last week as a warm up. Now it's time to get into it formally. All right, Mr. Griffin asked his students to place the following numbers on both lines. So, letter A, all right, is 1 5/10 here, and why aren't they lining up? Well, let's take a closer look at this. If we look at our number line, our interval is 1. Our interval is here still 1, but look, in between when they post a half and a half. So our plots are not going to line up, but they are still going to be accurate. So this is definitely negative 1.5 and negative 1.5. B is 3/4, so it's going to be greater than that. So I'll start here. Yep, it's almost to 1. And yes, it's right in between 1/2 and 1. 5/3. Well, if we wanted to change 5/3 to a regular number, we would just divide it, right? And we would end up with 1 2/3. So this is letter C. So I have 1, all right, and 2/3, which is just about right there. Yes, that works for me. And C is clear up here. Here's 1.5. 1 2/3 is right next to 1 3/4 or 1.75. Last one is letter D, negative 0.75. It works, negative 0.75. So absolutely, they are correct. They are correct, right? They just have different difference, right? And we're going to just call those, they just have a different scale, right? A different scale, all right? No problems yet. All right, let's get into the vocab here. The scale is the number by which the axis is marked. The values being graphed can determine the appropriate scale to better represent the ordered pairs. Okay? So we're going to start changing the scale up on these, and they've already done this a little bit because they went by 1/2 here. All right. So letter A, we're going to go ahead and then we're going to go ahead and list the ordered pairs, or we're going to go ahead and plot if they give us the ordered pair here. Letter A. So letter A is I go left and right first. Remember, X is 1, and here's 1.5. So in between 1.5 and 2 is about 1 3/4. We're guesstimating, estimating. So it's going to be an ordered pair of 1 and 1 3/4. Okay. The next one is letter B, -2 and -3.5. -2 and -3, right? And a half would take me right there. And let's put a letter B, right? Let's put a letter B. All right. Next one is letter C. Letter C is right here. So let's come over to the right to 2.5, and let's write that down. And then let's come down. Here's 1. Here's 1.5. In between 1.5 and 1 is 1 1/4. Excellent. Letter D, left and right first, back to -3. And then we're just going to come up right on the line. We have a perfect intersection. And these are a half. So it's, right, 1/2. Don't write negative. It's not down. It's just a half. And the last one is letter E, and they're starting to split it up here. 3.75. Okay, well, so that takes me about right there. So remember, 3.5 and 4, right in between that is 3 3/4 and 1.5. So here's 1.5, right? And that one puts us right there. We're going to call that letter E. Okay, so pretty good stuff there. Reading through this, which of the points on the coordinate plane satisfy the condition where x is less than 2 and y is less than 1? All right, so x, remember, x is here and y is here. So x is less than 2. Okay, well, that one is less than 2. That's less than 2. That is out. This is. So these are 3 that we can kind of look at right now. The other ones are eliminated because they're not less than 2. The x value is not less than 2. But now we have to look at the y. Is y less than 1, right? Well, that's not less than 1, so that is out. All right. Is that less than 1? Yes, negative is less than 1. So letter B is 1. All right. So that's 1. And then we have to check this one out. We had -3 on the first one. And is a half less than 1? Well, sure. It's half of 1. So that works too. So B and D work there. Okay. A little bit of algebra there, right? Which of the points on the coordinate plane satisfy the condition where x is greater than -1 and y is less than 1? Okay, so let's take a peek at this and let's just break it down and use our table here. So again, x is greater than -1. All right, so that is 1 right there. Okay, and I'm going to put a check over here. That's 1. Is x greater than -1 here? No. Yes, it is. No, it isn't. -2 is less than -1. And is x greater than -1 here? Yes, because it's +1. Now, we have to look at this other one. Now, y has to be less than 1. Okay, so is that less than 1? No, that's greater than 1. The next one we're going to look at, is that less than 1? Yes. Oh, I'm sorry. No, it isn't. That's greater than 1. Is this right here less than 1? And we have a problem here. I've made a mistake here on letter C. That's why I paused there. I forgot my negative sign right there. Yep. So that is 1 right there. This is not. See, that's a simple mistake by missing that. So the only one that where x is greater than -1 is here. That's 2.5. And y is less than 1, and that is less than 1. So I apologize about that. Just that little sign got me. And I'm sure some of you are going to catch that while you're doing the lesson. Let's flip the page and take a look at the next piece. Okay. All right. Luke is given the following numbers to plot on the coordinate plane. What should his coordinates planes extend from? All right. By what scale should the coordinate plane count? Use the blank graph at the right to help. Well, let's see here. We have to get to a number as big as 18, right, on the x-axis. And we have to get to a number as big and as small as, or as big as 12. So let's see, if we count by twos, right, if we count these by twos, right, and so let's see if this will work. All right, so this would be 2, 4, 6, 8, 10, 12, 14, 16. That's not enough, is it? Right? So what happens if we go up one more and count by threes? Will threes get us there? Well, sure. All right. So we could go 3, 6, 9, 12, 15, 18, 21, 24. So on our x-axis, all right, on our x-axis, right, the scale would be 3. I would count by threes there. Didn't say to graph. I'm not going to graph it. All right, but that would be the best explanation. Now, if this is by threes, we would make the y-axis by threes as well, right? So just remember that. Okay, but we had to get a number greater than 18 on the x-axis. Okay. All right, let's move on. Keno and Hope were asked to determine a scale for the ordered pairs, all right, listed below. Explain the difference, okay, and justify which group you would prefer. Okay, so let's take a look at these two. We have two different ones. So again, here's our x, and here's our y and our y. All right, well, let's take a look at this first one. Keno here. It looks like Keno had an interval of a half, 1, 1.5, 2, a half, 1, 1.5, 2. All right. And let's look at these, okay? Does a half make sense here, right? Yeah, it does because we have some coordinates here that are, in between a whole number. So a half would make this pretty accurate. But let's look what Hope did here. Hope has an interval of what? Really, it's one, but they're counting it. They're just showing the even number. So this is 1, 2, 3, 4, 5, 6. So when you look at this one and compare it to this one, what you'll see is you'll see intervals that are in between these lines. Okay, and here's another one, right? And that's a problem because we're estimating where those are. So to me, all right, Keno's is better because it's a smaller interval. And remember, the smaller the interval, the more accurate it is. Okay. So this makes more sense to me. I clearly can see where these plots are, these ordered pairs are, these points are specifically. Okay. And I hope that makes sense. Smaller the interval, the more accurate it is. Okay. All right. Let's continue on the bottom piece. And here we go. Down at the bottom, let me pull this other sheet down. Graph and label the ordered pairs on the coordinate plane. Okay, this will be good. So if you want to pause this and then do it on your own and then come back and check it, go ahead. I is -2, -3.5. All right, that's letter I. K is -5/2. Well, -5/2, so you might need to use your calculator. I'm going to go without it, but I'm going to go ahead and divide that, all right? And I'm going to get 2.5. So that equals -2.5, which puts me right in between -2 and 3. And then I'm going to go up 2, so it's going to be right there. And that's going to be letter K. Okay. When you have those improper fractions, either use your calculator or just divide it out. I know it's pretty small to see there, right? Next one, J, 3 seconds, which I know is 1.5, right? So 3 seconds goes over to 1.5, and 2 3/4 will go right there. So 3 and 2 3/4 will go right there. And again, you're just guesstimating here. Okay. So 3 seconds is 1.5. Okay. And we're going to come up there, and there it is, letter J. Last one is L. L is 3 and -3 seconds. Well, I know that is -1.5. We just said that last time. So 3 -1.5 will put me right there, and that is letter L. Okay. So little tricky here, right? It is, right? Last one. We're going to list these ordered pairs. Again, I would pause the video and check it. Let's go. So W is right here. So I know the interval's a half, right? So 1.5, and here's a half, and I'm going to call that 3/4. So 1.5, and I'm going to call that 3/4. Now, could I take that 1.5 and put 3 seconds there? Sure could, but it's just easier to write as a mixed number. Okay. Letter X is right here. So we're going to go back. And right here's the -1. So it looks like -3/4. And then we're going to come down. So let's write that down. -3/4. Okay, and then we're going to come down to X. Well, excuse me, here's -1. Here's -1.5. Right in between is a fourth. And that's -1/4, right? Letter Y is up here. We're going to have two positives because we're in the first quadrant, right? So 3/4, 1.5. Over 3/4, up 1.5. 3/4, 1.5. And then finally, Z is right there. I'm going to go back. Well, here's -1. So what do you think that is? That's probably going to be -1/4, right? So -1 1/4. And then we're going to come down. So when we go down, it's another negative number, right? So here's -1. So it's going to be -3/4. Okay. So You can check that if you're just turning the video back on and see what it's all about. Good lesson today, rational numbers. It's getting a little sketchy, isn't it? We flip this over. This is your homework. Take your time, okay? Because the rational numbers make it tricky. All right, guys, have a good day.